Okay, good morning. My name is Arne Martin, as Jan said. I work for a company that's not really important nor interesting right now. I was actually one of the 4 initial speakers announced for Rebels. So I'm proud to be the who the hell is that guy from the initial lineup. So happy to be here. Today I will be introducing Befurnished, which is my new enterprise-level Befurnished interpreter, which supports an arbitrary number of dimensions. It's multi-threaded, it's self-hosted, it has a super-fast tracing JIT compiler, and it also has a voxel.js-based editor, so you can navigate your Befurnished code in 3 dimensions. Really gives you a new way of doing this. This will change the way we think about lemmings-like programming forever. My notes say hold for laughs, but I don't, yeah, sorry. But 2 of you who thought that was funny, I'll buy you a beer afterwards. And so my actual talk is about React. I'll be talking at you for a while, and I'll hopefully do some coding in a bit. Like all chronic Yak shavers, I've written my own presentation tool, as you may tell. If you want to read some code that will literally make you want to gouge your eyes out with a spoon, you can check it out on GitHub. So, on to React. What's React? Well, it's one of the 10,000 JavaScript UI libraries out there. But it's not quite like all the other ones. It has a few special tricks up its sleeves. It's written by the dev team at Facebook, and the initial release was around a year ago, so it's fairly new. It's about creating self-contained and reusable UI components, and it's just for UI. If you need routing or persistence or Ajax or anything else, you need to provide that for yourself. So it's not a full-stack framework. Some use it as the V in MVC. You can use it with Backbone or other frameworks to do the views. But if you buy into the whole philosophy thing, you may not need to do classic MVC at all. So, why was React created? Sorry, this slide was written by my daughter. I'm on paternity leave right now, so it's a miracle I'm able to communicate with you verbally at all. Yes, React was created because the DOM is stupid, as we all know. And it's hard to work with. The DOM is, I like to call it a stateful mess. There's a bunch of frameworks that exist that provide two-way binding between the UI and your application state, like Angular, Ember, Backbone, Knockout, which is very powerful, but it can be hard to work with. And if you're not disciplined, it can get messy real fast. As you probably have experienced, if you've written any non-trivial application using any of these frameworks, the data flow can be really unpredictable, and you may have to add code everywhere to handle edge cases and partial updates and all kinds of those things. And it's also easy to get very tight coupling between models and controllers and views if you're not really careful. It's a typical multi-way data flow in MVC. But React tries to solve this. It has neither M's nor V's nor C's in the classic MVC sense. First of all, as I said, React is purely a UI library, so it doesn't do models at all. That's out of scope. And React components contain both view code and controller code. And MVC architect would frown at the layering violation here if it's not busy building a service factory, provider, helper, factory, something. But a smart person such as yourself will appreciate that this layering violation will allow you to have a very loose coupling between your components. Yes, so React allows you to do one-way data binding. Here's an example of how you can do that. This is something that Facebook call the Flux Pattern, or the Flux architecture. We have views, which are React components, and dispatchers and data stores. The views are initially rendered with data from the data stores, that's the S right there. The views respond to user events and call functions on the dispatcher. And the dispatcher is responsible for taking data from the views and putting it into the data stores. And whenever data in the data stores update, your entire application is re-rendered from scratch. That's kind of one of the crazy things about React. It will re-render your entire application every time there's an update. This allows you to treat your front-end JavaScript app like a stateless web backend app using your favorite technology stack, which means you get a clean slate on every request. You never have to deal with partial updates, and it makes things a bit easier. Now, I know what you're asking yourself. How does he maintain that perfect combination of smarts and charm? Also, isn't the DOM really slow? Isn't the DOM too slow to do this? Well, of course it is. The DOM is terribly slow. So the Facebook developers did the only thing that was sensible to them in their drug-fueled stupor, and they implemented their own DOM. They created a virtual DOM, and all React components render into this virtual DOM instead of the actual DOM. And this virtual DOM is then diffed with the actual DOM to create a set of the minimum set of changes that have to be applied to keep the virtual DOM in sync with the actual DOM. This actually works really well. Okay, so let's try and do some actual coding. Can you see this? Move it a bit. It's big enough? Right, so I'm using browserify or browserify here to load React. If you don't know what this first line means, don't worry, it will be explained in the talk later today, I think. Let's create our first React component. Let's call it my first component. Now, the way you create a component in React is by calling the create class function. And the create class function is named thusly because the person in charge of naming things was high as a kite that day. I have no idea what, yeah. It's a stupid name, but it works anyway. This function takes a single argument, which is an object literal. And the only thing that's mandatory here is a render function. And this function should return whatever you want to render. This could be a DOM element or another React component. In this case, let's just create a simple DOM element. React.dom is the DOM library of React, as you might have inferred. And there are constructor functions for all kinds of DOM elements. Just doing a div here. And the first argument here is a set of props that you pass into the element or the component. I'm not passing anything into it right now, so I'll just say null. And the second argument and the rest of the argument is the actual content inside the div. Just wait. Like so. If I've done everything correctly now. Sorry, yeah. And of course, it won't do anything yet, because I haven't put the component onto the page yet. So yeah, we have a first component, but we need to put it into the page, and that's done by the very sensibly named React.render component. First argument is our component. You have to call it as a function, otherwise it will give an error. And the second argument is the element on the page in which to put it. There you go. Hello, web browse. Nice. That doesn't really do very much yet. It's not very interactive. So let's make it a bit more interesting. Let's add a button. I love buttons. Okay, so let's lose this, and here we'll add a button. And we need to know what to do when we click the button. So I'm sending in the on-click prop. So I'm not going to do that. I'm going to just use, where is it? This dot handle click, and I'll implement that function in a moment. For the text on the button, it will say how many times it's been clicked. And the number of clicks is stored in the component's state. Also be more on this in a moment. Like so. So the button will say how many times it's been clicked. Now let's implement the handle quick function. And this function should do only a single thing, which is to update the state of the component with a new value of click counts. Like so. So when you click the button, it will increment the number of clicks by 1. But we need to know what the initial value of the number of clicks is. And that's done by implementing a function called get initial state. And this function should return an object containing the initial state of the component, which in this case is just clicks 0. Looks right? Makes sense? Let's see if it works. 1, 2, 3, 4, 5. Nice. So each time we click the button, this function is called, which sets the state of the component. This will trigger a re-render of the component, which will then be rendered into the virtual DOM, which will be diffed with the actual DOM to apply the actual changes that are needed to make the number go up. But not all changes are initialized by user actions. So what I'm going to do is to add a counter to the page that will count the number of seconds since the component was first rendered. I'll just put this below the button here. Just a new div with no props. It'll say this dot state dot seconds. Seconds have passed. Like so. And we need to put the seconds into our initial state. That should also be 0. And we need, when the component is rendered, we need to set an interval that will be called every second to update this counter. Now, React has a bunch of life cycle methods that you may implement on a component. And these methods will be called at a certain point during the life of a component. Get initial state is one. I'll add another one here. It's called component did mount. And that's a function that is called after the component has been put onto the page and rendered for the first time. And here we'll set an interval. Inside this function, we'll call setState again. And we'll call it every 1,000 milliseconds. And we have to bind this to this function, because this in JavaScript is, well, you know, stupid. Okay, so now the interval is set, and it will run every second. But if the component should ever leave the page or be unmounted from the page, we need to get rid of this interval, stop it, clear it away, clean up our mess. So we have to store this, the ID of the interval somewhere. I'll just say this dot interval equals that. And then I'll implement another lifecycle method, which is called component will unmount. That's a function that's called just before the component is removed from the page by React. And here we'll simply say clear interval, this dot interval. Now, if we're lucky, let's see if this works. Nan. Nice. This dot state of seconds, of course. Thank you. Right. That's it for my first demo. Let's go back to the slides. JSX. There's, I don't know, in the haze of pot smoke filling the Facebook offices, the developers all agreed that having a solid JavaScript API for doing DOM and writing components, that's not good enough. So they implemented JSX, which is a batshit crazy way of putting HTML inside your JavaScript, like this. Yeah, I don't know. This will transpile into the oh, you can see the edge of the slide. There you go. This will transpile into this JavaScript, which makes much more sense if you ask me. But yeah, thankfully this is purely optional, even though many of the examples in the documentation use it. I guess I don't really like this. I guess I'm opinionated in that way, so I'm not going to waste any more time on it. My talk has something about mobile in its title. The title of my talk was originally going to be Mobile-Friendly UI Components with React. But as I worked on it, it turns out there's not really a whole lot you can do to make your React components more mobile-friendly. And there's very little that's React-specific. What's that? So I changed mobile-friendly into not mobile-unfriendly to make it put a bit more, bit less emphasis on it. Well, the general rules of mobile friendliness apply. Don't rely on hover. Consider small screen sizes when designing. Don't include tons of fonts and images and megabytes of JavaScript and CSS. Just think about the performance. Profile your app for performance. None of that is really React specific. There's one thing though. If you want to do touch events in your components, you have like handlers for all kinds of events, like on-click and all the mouse events and the keyboard events. But if you want to do touch events, you have to do initialize touch events before you render your first component to make them available. I think this will go away in the future, but at the moment, this is what you have to do. So while I'm talking about mobile, I'll just do a digression into Topcoat. And if you use Topcoat, couple guys, yeah, it's a great CSS library by Adobe. Topcoat has a bunch of CSS components for the buttons, lists, checkboxes, other UI elements. And it has a focus on making the rendering really fast, which is good for mobile. There's also a couple good mobile themes that makes Topcoat very good for prototyping mobile web apps. And I'll use Topcoat in my next example, which will be now. Now, I don't really have time to write all this code for you, but it's a very simple app. It's under 100 lines of code. And I'll show you what it looks like first. It's a very simple note-taking app. There's a text field on top. There's a list of notes below. I can add a note, edit notes, and everything updates in real time. So this app is made of, there are 4 main components. It's the text area up here for editing the note. There's a list down here for viewing the list of notes. And there's the button down here for adding a new note. And there's one main component that wraps all the other components and contains them. And this component is also responsible for keeping all the state of the component. Now, React components have both props and state, which can be a bit confusing because they're a bit similar. But I'll try to explain the main gist of the difference between them. Props is data that you send into the component when it's rendered. A component will or should never change its own props. Props will always be passed in from the parent component. Props can be all types of things like other components, functions, simple values, objects, everything. State is data that's internal to one specific component. It should never be changed by outside components. And it's usually changed by the component that owns it as a result of user actions. So yeah, this app has a few basic components. Here's the note list. This returns a Topcoat list. I'm using React Topcoat, which is a very simple React library for that wraps all the Topcoat components. It returns a Topcoat list, and it has, as one of its props, all the notes that's in our app. It maps over them, and for each, it returns a new li element, which gets a class name if it's the selected one, and it has an on-click handler that calls the select note function. That's fairly simple stuff. Our note view component, that's the one on top that's responsible for editing the note. That's very simple. It's basically just a text area. The value of the text area is the text of the note. And whenever that text is changed, it calls this save note function. And this again calls the save note function that's passed in as a prop with a current value of the text in the text field. Very simple. And so when the app is rendered, we first have the note view, and it's passed in the text of the current selected note, and a function to save the note. The note list is passed the list of all notes, which note is the currently selected one, and a function to select a different note. And the button on the bottom is sent a function to add a note. And these functions, select note, save note, add note, are very simple. All they do is modify the state of the component. And the state is very simple. It's a list of notes, initially just an array containing a single note. And which note is the selected one, initially the first one in the array. That's basically it. It's a fairly simple app, and it's pretty and nice, and it works and everything, but it's not really useful because if I refresh the page, everything goes away because it doesn't save anywhere. So what I'll do for you is I'll implement persistence on this component using local storage. That's very simple. First thing I'll do is I'll implement a lifecycle method, another one of those, called component did update. This one's called whenever the component is updated. Yeah. And all we want to do here is to save the current state of the component into local storage. Notes. And we'll just stringify the entire application state. Right. So this means every time a node updates, the entire state is saved into local storage. Now, all we need to do is get hold of this when the component is rendered for the first time. So we'll go into our getInitialState function. And we'll try to retrieve the nodes from local storage. And if we have it, local storage.getItem will return null if the item doesn't exist. If we have any nodes, return JSON.parse the nodes. Otherwise, return the default. Using an equal sign. Does this make sense? Yeah? Hopefully. So now if I refresh this, and I edit this text, I add a new node, and I then refresh the page, everything is stored. It even saves which node was selected. Right. So that's it for my demos. Okay, I'm almost done with my presentation. I have one more side note about error messages. I didn't have anywhere else to put this, but I thought I'd just squeeze it in at the end because I think it's a pretty cool thing. When you're developing with React and you're using the development build, the error messages are really good. They will actually try to explain to you what you're doing wrong and what you can do to fix it. So here's an example. Say you want to create a div, and you want to set the style of this div. So you pass it in a string of CSS, which sounds like a reasonable thing to do. Well, actually, it's not. That's wrong. But you'll get an error message that looks like this. The style prop expects a mapping from style properties to values, not a string. That basically tells you exactly what you did wrong. So now you know that you should do this instead. Just send in an object. Okay. So that's it. So my wrap-up is, yeah, React is a thing that exists in the world. I really enjoy using it. I think you would too. You should try it. It's a really solid library. And yeah, that's it. Thanks. Nice. And all the code and all the slides and everything is available on GitHub.
All right. Great job. Thanks. Can I invite you over?
Thank you.
Good job. I'll take this opportunity for a commercial interruption that isn't actually commercial but open source. So Arne talked about how to make this persistent, and you showed the 2 lines of local storage code. I work on a thing called Hoodie, and Hoodie is exactly for doing what you just did with the local storage stuff. It's the same 2 lines of code with a little few different identifiers, but you not only get storage, like local storage in your data, you get synchronization to the server, you get user authentication, so you can log into your account and get all your data and sign in from different accounts and all that kind of stuff, and lots of other goodies.
It's very good.
Yes.
That's true.
So you should have used that for your demo.
I'm sorry.
Anyway, I have awesome Hoodie stickers with me. There's some around, some in the back. If you want to talk to me about Hoodie, let me know. Anyway, ching. End of commercial break. So the biggest question that people had is, how did you do your slides?
Yeah, as I said, I've written my own slide tool that basically parses a specified markdown format and tries to render it to the console.
Okay.
Yeah,
that works pretty well.
The code is basically a single random spaghetti, so I recommend you don't read it.
Okay. Okay, what it is on GitHub?
Yes, it's on GitHub.
Excellent. What is it called?
Slid.js.
Okay, there you go. Have you used React together with other full stack frameworks?
No.
Good. Excellent.
And I don't think I would.
Why?
I'm not really a huge fan of the big full stack frameworks. I did a really big project using Angular, and that kind of burned me on using Angular.
Okay.
So yeah.
So you said that, so no background. So the first time I heard about React was at JSConf US last year, and Pete Hunt gave a talk, and they made a really big deal about the JSX, the writing the HTML inside, and we're all like, what? Because like SpiderMonkey has a thing called E4X where you can do native XML in JavaScript, and that never really worked, and it's kind of nice if you really need it, but if you mostly don't need it. And then the whole goodness that React is was a little bit lost in the message of what the hell is going on with that, with the markup. So at JSConf EU, the half year later, they gave a proper React introduction and skipped all the bits. But now the question is, if you're actually doing markup, why not use a markup language? What's so bad about it? Well, you said you don't like it, but like...
I think it's kind of stupid, and they focus so much on it, and it detracts from the whole... React is a very good library. As it is, it doesn't need the JSX thing to be good and useful. And the JSX thing just steals so much focus.
Okay, well, that's exactly what happened at the talk.
Yeah, and it's really, I think it's pointless.
Right.
Maybe it's good if you have designers that only speak HTML and you want to bring them into this, but that's not the case for me. So.
Excellent, good point. Oh wait, I'm in the wrong thing. Let's see. There were so many good questions. So, did you do any performance testing with, especially Chromium telemetry, and like on the Topcoat side, and what made you pick Topcoat for that, or did you? Sorry, is that what made you pick Topcoat?
I just think it's neat.
Okay.
Yeah. I know that Adobe have benchmarked Topcoat very heavily, and they have published all their benchmarks on their website, so you can just go take a look at that if you want to see it.
And you've independently verified that also...
I have not.
Yeah. As nobody does that, right? The most important questions for the end. You introduced Bifunge earlier. Do you support Bifunge 93, or is it just a 3D version of the original implementation?
It's 93, of course, yes.
Okay, excellent. Okay, and are you planning to start Bifunge Inc. and work on it full-time, or are you pursuing venture capital? Or
I was considering doing a Kickstarter, but we'll see where I take it.
Right. Okay,
I haven't really decided yet.
I think that's all the questions
Yes?
we have. Thank you very
Thanks.
much. All right, good job. So it's time for our first break. Coffee should be ready for you. People are